So what am I about to start is integration by partial fraction. So what this is all about. So first thing what we need to know that it's all about fractions. So one thing we have read about rational numbers. Now rational numbers are what? Numbers which are expressed in the form of p by q form where q is not equal to 0. This is what we know about rational numbers. Now in here in this portion we will be starting to know about rational function. So what are rational functions? Rational functions are those functions which are expressed in the form of px by qx provided qx not equal to 0. So these are rational functions. Now where px and qx are polynomial in x. So they are nothing but polynomials in x. Now once I say that they are polynomial in x, so an example wise I can say that x plus 1 divided by x square plus 2, this is a rational function. Then x square plus 2 divided by x plus 3, this is also a rational function. Then I say x cube plus 2x plus 9 divided by x cube plus 7. So this is also a rational functions. So why have I written 3 different examples? The reason is I will tell you. So what is the basic thing about these 3 is that you see the first one. In the first one, what do you see? The degree of the numerator is less than the degree of the denominator, right? The degree of the numerator is less than the degree of the denominator. Now in the second one you see that degree of the numerator is greater than the degree of the denominator, and the last one you have degree of the numerator equal to degree of the denominator. So when you have these two cases, whenever the degree of the numerator greater than equal to the degree of the denominator, we call them as improper rational functions. This one we call them as improper rational functions. Now integration of these functions are a bit difficult to do. They are not done. Integration of improper rational functions are not performed. And the last one, that is degree of the numerator is less than degree of the denominator, these functions are known as proper rational functions. These are known as proper rational functions. So an integration of proper rational functions can be easily done. It can easily be done. So whenever improper rational functions have a given, so what I basically do is we have to convert that improper rational functions into proper rational functions. Then only we can proceed with it. Okay. So we have to convert this improper rational functions into proper rational functions. So how do we do that? Let me show you an example. So suppose we have an x cube minus 8 divided by x minus 2. Suppose we have this problem. Now we have to convert this into proper rational function. So how do we do that? Now x cube minus 8, the degree of the numerator is what? 3, and the degree of the denominator is what? 1. So degree of the numerator is more than the degree of the denominator. So this is an improper rational functions. So we have to try to convert it into proper rational functions. So how do I do? So what I will do is I will write here this one as x minus 2. I know what is a cube minus b cube formula. So the formula of a cube minus b cube is what? It is a minus b, a square plus ab plus b square. That's the formula, right? And so here I am going to write x cube minus 8. The formula will be what? X minus 2 x square plus, it will be what? ab. So it will be 2x plus b square means 4 because b is 2, and divided by x minus 2. So what do you see that x minus 2 gets cancelled. So we have a function, it's like this, x square plus 2x plus 4, and it's very easy to integrate. So basically whenever we have an improper function, we'll try to convert it into proper function, then we can integrate that. Okay, so that's the basic method of integration. Now, there may be different rational functions. Now, how to convert